video, I'm going to do a hand construction for you. We're going to be looking at something called the circumcenter. Okay, so we're going to follow these steps. Construct a triangle. We don't have to do that. We already have a triangle here to work with. But we're going to construct the perpendicular bisector for each side. So we're going to do that construction 3 times in this triangle. So this is something we already know how to do. So this is where I want to open my compass to a little over halfway, and I want to make an arc above and below. Okay, I want to keep that same distance on my compass. I didn't change the width at all. And then I'm going to put the sharp part on the other end and draw my arc above and below so that it crosses those first arcs that I made. And then I'm going to take my ruler, my straight edge, and I'm going to connect those 2 intersection points. And I'm going to extend my line a ways. Okay, so we want to make it nice and long. Okay, so I did it for this bottom side. I'm going to do it for the other 2 sides now. Okay, and I'm just going to use the same width as long as it's over halfway of the side. That's all I need. Okay. Okay, other side. Okay, connect those 2 intersection points. So this one with this one out here. Draw our line nice and long. All right, we have one more side to do that for. And I know the markings do get a little bit funky. They start to all cross a little bit, so try and keep track of which ones are your most recent ones. If you need to erase some of the previous ones before, you sure can. Oh, this one's gonna cross in the same spot as another one. All right, so this intersection and this intersection connect with my straight edge. Again, trying to draw my line nice and long through the triangle. Okay, so if you guys notice, and if you did your construction very accurately, all 3 of our perpendicular bisectors, those 3 lines we just drew, should all intersect at the same point. So mine intersect right here. I'm going to draw a point there to make it kind of stand out. This is called the circumcenter. Okay, so filling in the blanks down below. The point where all 3 perpendicular bisectors intersect in a triangle is called the circumcenter. Okay, so this question says, what do you notice about the distance from each vertex to that intersection point? So I'm going to label this guy ABC since they are referring to it as triangle ABC. Okay, so I'm going to use actually my compass to look at the distance. So I'm going to look at, okay, from that intersection point to A, it's that distance. It says, what do you notice about each vertex? Well, without changing my compass, it's the same from that circumcenter to B and from the circumcenter to C. So that circumcenter is the same distance away from each vertex, okay? So, and I'm actually going to name this point too. We'll call it X, that intersection point. So I'm going to say X is the same distance away from each vertex. So the relationship described by, well, you probably could have guessed it from the title of this lesson, is called the Circumcenter theorem. That the circumcenter is always going to be the same distance away from each vertex, okay? So this intersection point, or point of concurrency, again, is called the circumcenter. And this, we're going to use this point of concurrency as the center of the circle. So we're going to construct a circle that passes through the vertices and has a center of X. So I haven't changed my compass, so it should still be the same, but I'm going to check. So there to a vertex. So I'm going to use that to construct a circle. Oh, and try not to move my end here. I always like to actually move the paper instead. I feel like I'm more accurate that way. And I'm creating a hole in my paper, I think. There we go. All right, so all I did is I put the pin on my circumcenter on X, and I made sure the distance of the compass was what it needs to be from the circumcenter to a vertex, and I constructed a circle all the way around using the compass. So this just illustrates that point even further. I'm gonna use a different color here. So this distance from each of the vertices to that circumcenter, those are all the same distance. And it kind of makes sense actually seeing the circle there, because these orange lengths that I just drew in are the radius of a circle. And we know that no matter where I draw the radius, if it's within the same circle, those are all the same. So I'm going to put some congruency markings on there. So this circle that goes around anything actually, but in particular this triangle where the vertices are touching the edge of the circle, this is called a circumscribed circle, which makes sense because its center is the circumcenter. So circumscribed is what we call that circle. Okay. All right, so that's how you do the hand construction for the circumcenter and a circumscribed circle. You construct the 3 perpendicular bisectors, use that intersection point as the center of the circle. Okay, so now we're going to look at some problems involving the circumcenter theorem. So we kind of already established these definitions and the theorem, but this is out of your book, you guys. So concurrent, you may have seen that on the previous page, but it just means when 3 or more lines intersect at the same point. So in a triangle, perpendicular bisectors are concurrent. We call that point of concurrency the circumcenter. And we just discovered the theorem, right, that the distance from the circumcenter to each vertex is the same. So in this image, PA is congruent to PB is congruent to PC. And notice I drew those in and wrote in that conclusion. Okay. All right, guys. So now let's solve some problems with this. All right, so it says KZ, LZ, and MZ are all perpendicular bisectors of this triangle. Okay, KZ, LZ, MZ. So where they intersect then, remember, is the circumcenter. So Z then is our circumcenter. So based on the circumcenter theorem, Z is the same distance away from G as it is H as it is J. Okay, they want me to find ZH and GM. Okay, so let's start with ZH. All right, so ZH is this length. So I know that this length, and this length are all the same. Z is the same distance away from each vertex. So this one is given to me as 19.9, so that means all of those are 19.9. Okay, the other one I'm asked to find is GM. So GM is this length down here. Well, I was told that MZ is a perpendicular bisector, so it's bisecting this side, JG. So that means if this half is 14.5, this is another half of 14.5. So not a ton of math involved here, you guys. We're just recognizing that relationship and also using our definition of perpendicular bisector to find some missing side lengths. Okay, this one says find the circumcenter of triangle RSO with these 3 vertices. So R is at -6, 0. S is at 0, 4. I should label those R, S, and O is at the origin. Okay, so I'm going to draw in this triangle here. So I got a right triangle sitting here. So it says find the circumcenter. So the perpendicular bisectors where they intersect is the circumcenter. So we could do all 3 sides. We actually don't have to. All 3 intersect at the same point. So as long as I find at least 2 to see where they intersect, that's enough. So I'm going to choose to do the horizontal and vertical side because those are easy to draw in. So this side, RO, it's 6 long, right? 0 to -6. So the bisecting point would be at -3. And because it's horizontal, its perpendicular bisector is going to be vertical. Okay. SO goes from 0 to 4. So the bisecting point would go through 2. And it would be horizontal in order to be perpendicular. So I can see it's going to intersect there. If I found the perpendicular bisector of RS, it would also go through that point. So that has the coordinates -3, 2. and that is the coordinates of the circumcenter. All right, that's it for this video, guys. Thanks for watching.